All right, so that's objective 2. So we're going to look at the sampling distribution of p hat and talk about it being approximately normal. Very similar again to our sample count from section 6.3. So you should pause this video. You should go do this activity in Edulastic and then come back. All right, so hopefully you returned back from the activity and you see that we're going to talk about this large counts condition again. If you recall, we did talk about this in section 6.3. So again, the large counts condition, sorry. So it says, suppose p hat is the proportion of successes in a random sample of size n from a population with proportion of successes p. The large counts condition says that the distribution of p hat will be approximately normal when, and again, these two things must be true. Again, remember, it's talking about we have to have enough successes and enough failures in order to even do the problem. Okay, so keep that in mind. Same idea as with your sample counts. Okay, so example 2, it says a penny for your thoughts. So Mr. Ramirez's class did the penny for your thoughts activity. And again, that was the activity I explained with some of the dot plots from the first video in terms of I have a big jar of pennies. You're pulling out pennies, and in this case, they're looking for the proportion. So it says in his population of pennies, the proportion of pennies from the 2000s. So again, still looking for those pennies minted in 2000s. So this is the population proportion. This is the proportion of pennies in his jar, in my jar, that come from 2000s. P equals 0.627. Would it be appropriate to use a normal distribution to model the sampling distribution of p hat for samples of size n equals 16? Justify your answer. So here's our p value, here's our n value. So let's do it. N times p. I'm just going to use the calculator off to the side. I'm not going to go to the graphing calculator here. So when you multiply 16 times 0.627, you get 10.032. If you just run around to 10, I'm okay with that, but I'll put 032. That is greater than or equal to 10, so that is good. And now we do n times 1 minus p. 16 times 1 minus 0.627. And that is 5.968. And that is less than 10. That is not good. Is it appropriate? No, this would not be approximately normal. Not approximately normal. This is a big deal because if I were to ask you to find a probability of something, you could not use a normal distribution to do this. That's why we check this large counts condition. That's why anytime you do a problem that involves finding a probability, you have to check the large counts condition if it is a sample proportion problem. Okay? All right. Good deal. So that was objective 2. Objective 3 is coming. This is where we put it all together and do one of the big probability questions.